Hello everybody. In this video we're going to talk about another classic SAT problem which involves trying to solve some sort of bizarre looking equation for a specific variable. Now, one thing that I do want to caution you about strategically is that you really don't need to read the filler text. Right? They'll put something in there that explains what this function is or what it does, some background on it. But we don't need to read that. It's a time waster. We're just going to have to figure out how we rearrange these equations in such a way that we solve for a specific variable, right? And it looks from our answer choices, I'm not even reading over that, it looks like from our answer choices we are trying to figure out what is v, right? So v right now is buried inside here in this root, in the denominator, it's squared. We want to just end up with v is equal to something, okay? Now, one thing that I would recommend that you do is make sure that you are very familiar with these set of rules up here. I would recommend pausing the video and taking a screenshot and making sure that you are comfortable with all of these exponential rules and the link between roots, the radical signs, and exponential fractions. Okay, I might make a video on this in more detail later, but for now, make sure that you understand that. Okay, so back to this problem. It's going to be a little involved, but let's go ahead and try this. And, oh, by the way, I have a hard time writing these Greek symbols here, so if you forgive me, I'm going to say that squiggly looking Y thing, I'm just going to write it as T. Actually, I'm just going to write it as Y. Alright? Hopefully everybody's, okay with that. That's what I mean by this. Alright, but let's go ahead and figure this out. So we start off with Y is equal to, I'm going to get some outraged comments. Like, that's not Y. That's not what that is. Relax, okay? I'm not trying to fundamentally deny physics here. Okay, but anyway, so here's what we got. Well, the first thing that we always want to do, if we're trying to solve for something, particularly if we're trying to solve for something that's found in a denominator, is let's get it out of the denominator. Easiest way to do that is multiply both sides by that weird-looking radical. So let's just do that. 1 minus v squared over c squared. Do that to both sides. So I got to multiply that by the same thing. That's, I don't know if I need to write it out again, but for the sake of completeness, let's just do it. Okay, so then, well, these cancel here, leaving us just with 1. And then we've got the radical out of the denominator, which makes it easier to simplify, to solve it. We got that times y is equal to 1. Okay, well, next step we could do is we could move the 1 over to the other side. Because again, remember our goal is to strip everything away, and we're just left with v all on its lonesome on one side. So, let's do that. Let's switch up colors here. Let's do light blue. So that would get us to, if we divide both sides by y, we have this radical, 1 minus v squared over c squared, is equal to 1 over y. Alright, next step. Well, we can't really do anything with the v until we get rid of that root, the radical sign. So the easiest way to get rid of that is just square both sides, right? So I could just say this squared is equal to that squared. Well, where does that get us? Well, whenever you square a square root, you just end up with whatever was inside. So that gets us now to 1 minus v squared over c squared is equal to, well, we square this, hopefully, check my math, but this should just be 1 over y squared, right? Because it would be 1 squared, but that's just still 1, and y squared, well, that's going to be y squared. Okay. And then the next thing we could do, there's a couple things we could do. Maybe we could move the 1 over there. We could subtract 1 from both sides, right? That would get us to, here, we get minus 1. And now we're at negative v squared over c squared is equal to 1 over y squared minus 1. Well, I want to get rid of that negative because I know we're going to need to. So I'm going to multiply both sides by negative 1. So that would switch the signs for each of these terms. And that would get us to, let's see, this would now become positive v squared over c squared is equal to, basically just sort of flip things around. Instead of negative 1, we now have positive 1, and instead of positive 1 over y squared, we now have minus 1 over y squared. Okay? So far, so good. Well, then the next step that we could do is we need to get rid of this c squared. And that's easy enough to do. We just multiply both sides by c squared. So let's just go ahead and do that. That gets us to, I keep saying that gets us to. Sorry, I need to switch up my vocab here. V squared, I'm going to do a deep voice too. V squared is equal to c squared times all of this. Now, you could distribute the c squared in there, but don't do it yet. Just hang on. Sometimes that's unnecessary, right? Because we could do c squared times that, and then c squared times this. But just let that hang out for a minute. All right? Then the last step is we need to get rid of that square sign. And the way that we do that is we would just take the square root, right? So if we take the square root of v squared, we also have to take the square root of this entire thing, right? So I'm going to put a gigantic square root sign, and that would be c squared times all of this, 1 minus 1 over y squared. Okay? Well, here we go. The last thing. If we have v squared and we took the square root of that, well, the square root of a square is just the thing itself. So that's just v. And boop, boop, boom. That's exactly what we were trying to get to, right? So we have v. And all we have to do now is clean this up just a little bit, and we have our answer. I think what we can do is we could, and again, just review over your radical rules if this doesn't make sense to you. Whenever you have a bunch of terms being multiplied together, you can do this mathematically. You can say that's the same thing as each of those terms separately taking the square root of them, which in this case would be 1 minus. We have to do the whole thing, right? Because it's times all of that. Okay? So that's really what we can do. Well, the square root of c squared, same logic for the v, that's just going to be c, right? Now this one, though, the temptation would be, oh, we have a y squared in here, that can become what? We can't do anything here because we have a sum. We're adding together things. So we have to take the root as a whole, but we can't really do that because we can't really combine these things together. It makes things messy. Okay? So just rule of thumb is that if you have addition or subtraction going on with your terms in a root, you just have to leave it go. So that gets us to v is equal to c times, just leave that root be, 1 minus 1 over y squared. And there we go. And that looks like that is answer choice. Looks like that's answer choice D. I always like saying answer choice number D, but you know what I mean. Okay, that was kind of intense, and this video ran a little bit long, so I'm going to pause here. Let's do another one, and just as for more practice. But I do strongly encourage you to review over these steps to make sure that you're comfortable with them, and also take a screenshot and review these different exponent rules.